This logic expression question is tricky but solvable. Hello guys, welcome back to my channel. My name is Uche Nnamdi Nicholas and today we're going to be treating this logic expression. And this is the question from the 2025 October November paper 2-1 of computer science Cambridge IGCSE. And the question we're looking at is the question number 4C. So the question says the restaurant offers a discount on the meal if the person ordering is either a student or is 65 years or older. Okay, so let's take note of that part. I'm going to get the text too there. So we want our x to be equal to, so it's either you are a student or is 65 years. So for you to be a student, so that's the A part. Okay, so let us write the A first, okay, which is the inputs here, which stands for the student. It says or, so we need the or gate, or 65 years or older. 65 years or older, that's the B part, which is the B input here. Okay, so let's put a bracket there to separate this left hand side. Now, the other part says that the discount, which should be equal to 1, can only be given if the amount of the order is $20 or more, I believe. Yes, or over. Okay, so $20 or over, that will be this one, which is C. So that means there's an AND operation there. Okay, so this condition must be met, and this condition equally must be met. Now, the trick there is this: if there is a chance that we would have a 0 here, that means this, once that 0 ends with whatever value we have here, we will have a 0. But we need to guarantee that the s has to be equal to 1. And the only way we can guarantee that is by negating this AND operation, I mean this A input here, because for the student to be present, this has to be 0. Yeah, so that means being 0 is not 100% certain. So we need to do not A, so that we can be certain that it gives us a 1. So that all of the operations gives us a 1. That way we are certain that this x is going to be a 1. So that's how you do that. Now I can pick this up and drop it here. Then that will be okay for us. Good. So I hope that part is clear. Okay. Now we're going to handle this logic circuit part. So we're going to draw this. So each logic gate must have a maximum of 2 inputs. Do not simplify this logic expression. Okay, so we're going to draw this, okay, here using this very logic expression. Drawing the logic circuit using the logic expression. So how do we do that? We walk our way from the bracket, within the bracket, and then we walk our way out. Okay, so if you check here, the bracket has left hand side and the right hand side, so you can start from anywhere, but I would like to start from the right hand side, I mean the left hand side, because of the NOT A. So let me draw the NOT gate. Of course you know the NOT gate. I am currently using my my touch pad from my laptop, so do not expect a perfect drawing. Yeah, but the shape would largely look recognizable. All right, so that is the NOT gate with a circle right there. Good, and then a line. So this is the NOT gate. Okay, so NOT A. So here now will give us the NOT A. Now we need to put an OR gate there. Oh, sorry. Now the OR gate has 2 curves. A curve. Now, from my record, over 90% of you who watch my videos are not subscribers, and that is a staggering figure. So I want to use this opportunity to remind you to subscribe, like, share, hit the notification button, and even comment. That way this video gets to as many persons as possible, and we are encouraged to do more. Now, have you done that? Thank you. Let's continue. And another curve. Let me take it from here so that it looks better. Ooh, doesn't look good, but you basically understand, right? Yeah, that's the OR gate. Okay, so I'm going to drop this here. So if you're using a pencil, of course, your drawing has to be a lot better than mine. Okay. Um, and so here we have the not A or B. All right. So now we need to add the C input to the AND gate and join all of them together using an AND gate. So let me draw the AND gate here. Now the AND gate is a straight line with a curve. Straight line with a curve. Yeah, so this looks better than my OR gate. Okay, so I'm going to drop this and then I'll draw this line. I can just draw it straight, right? Let me try to be a good student. Okay, good. So that way we can now link this to the X, which is the output. So that is the symbol, I mean the logic circuit for the logic expression. Okay, so you can as well just double check to be sure that everything is okay. I think everything is okay. Now let's move on to the last part where we need to draw the NAND gate. So draw the NAND logic gate symbol and complete the truth table for it. So here is where we're going to put the NAND gate. Now the NAND gate is an inverted AND gate. So you AND first before you invert. Yeah. So so let's draw the input. Uh, two inputs will be just fine. Okay, considering the truth table even here. Okay, so first of all, you draw the AND gate, and then you draw. Let me complete this line here. Good. And then you put the sign of inversion, which is the circle that is usually there with a line coming out for the output. So that is the NAND gates, not like the best of NAND gates, you know, in the word, but this is recognizable that you should have the mark. But of course, you're using your pencil, so make sure that the drawing is better. Or do you want me to adjust this a bit? Okay, let me not be a lazy student. Let me adjust this a little bit and put it somewhere there. Okay, so this looks better, right? Okay. So now, for the truth table, you need to do the AND operation before you do the NOT operation. So 0 and 0 is 0. When you NOT it, you have 1. 0 and 1, 0. You NOT it, you have 1. 1 and 0, 0. You NOT it, you have 1. 1 and 1, 1. When you NOT it, you have 0. So that's basically an inverted AND gate. Okay, so with this, we're done with the questions. Now, have you liked this video? Have you subscribed? Have you shared? Please, if you've not, do well to like, share, subscribe. That way this video gets to as many persons as possible. You can as well let us know if there is any section of this question you want us to look at. Okay, that way we can prepare the video and make sure that you get it as soon as possible. Thank you, guys. I'll see you guys again in the next video. Bye for now.